All right. Experimental design all the way from the first week of school. Let's take a look at our vocabulary. It was lots of vocabulary. Remember, it was not very mathy, and y'all were going, what the heck? This is not a math class? What are you talking about all these words for? Okay? All right. Sampling methods. Bad ways to sample. Voluntary sample. What kind of bias do you get from a voluntary sample? What? Voluntary response bias is the type of bias, and it's happening because only the people with strong opinions will take the time to call in. So next, convenience sampling is convenience bias. That's if you it's made up of people who are easy to reach. You just ask the people at the mall, or you just ask the people at your church, that kind of thing. Now, what you run the risk of with convenience sampling is that it might not be like the population. If you ask the people at your church, is that going to be representative of all of Aledo? No. So what is that called? What type of bias is that called if it's not like everybody? Undercoverage. Very good. So undercoverage is the type of bias if it's not like the whole population. All right. Here are good ways to sample. Simple random sample. What's our quickest and easiest way of simple random sample? Babies in a bag, shake well. Okay? Now look at the way that this I got off the internet does this. Assign a number 1 to 100 to all members of the population. One number is selected at a time. And yes. By Thursday. T-shirt things by Thursday. And pick random digits or using a random number generator, find the first 10 selected without repeats. Okay, I'm pretty sure I'm like, okay, babies in a bag, shake well, pull out 10 babies. Sounds good. Now, if you're afraid to use that because you're like, you can't put babies in a bag and you feel strongly about that, then, oh my gosh, write a number on each one of the baby's diapers and put those numbers in a bag and shake those numbers well and then pull it out, okay? All right. Stratify sampling. So stratify makes what kind of groups? Stratify. Oh, gee whiz. Thank you. Yes. Stratify, homogeneous. Every single group is homogeneous. Stratify, homogeneous. Hey, here's the deal. Listen, here's the key. You get all kinds because I get you and some of all of you. That's why you stratify. If you want to make sure when you ask 100 people at Aledo High School that you are getting some freshmen, some sophomores, some juniors, and some seniors, you're going to stratify and get 25 freshmen, 25 sophomores, 25 juniors, and 25 seniors. Otherwise, you run the risk of getting, depending on when you ask people, what if you ask them 7th period? What proportion of seniors are you going to be getting? Not very many, yeah. So, if you want to make sure you get a representation of everything, then you might consider stratifying and then take a random sample from each of those stratified groups. Okay, cluster. Hey, cluster, you're a group. Okay, we remember that one. I will sample all of you. Hey, cluster. Hey, cluster. So if I pick one cluster, and this cluster is supposed to, I'm going to sample all of that in there, then this cluster better what? Represent the population. This cluster better be a mini-me. Okay? So that's what I need to happen. So you can do cluster sampling if you think the clusters that you have divided into are mini-me's of the population. The example they give on this is randomly choosing some high schools across the country. I guess they think that by randomly choosing high schools, they'll get a good representation of the different kinds of high schools, and then they'll sample all of those, which will give an overall representation of students. All right. Multi-stages just means everything. And what about systematic random sample? Systematic. Picking every 5th one, every nth one, whatever. Make sure you start at a random place. So you pick a number out of a bag, And you pick the 6th person that walks in the door. See, that was your number, 6. So make sure you start at a random place and then pick every 6th one after that. All right, very good. Now let's go on to experimental design. First of all, I want to talk about what's the difference between an experiment versus an observational study. So an observational study does what? You observe already existing conditions. Okay? You are going to observe something that already happens or has happened and then get your data from that. Whereas an experiment, what's the key there? You design it yourself, true, but I hear it. I heard it. Treatment. And you randomly assign to the treatment groups, and you are allowed, then ultimately it allows you to do what? Well, you can't, what kind of conclusion can you draw? Cause and effect. Okay. So with an experiment, we know that we have to have a treatment. Okay? All right. So now let's for an experiment. Now, if you, I don't have this on this page, so let's write this down. If you randomly select from the population, that does not allow you to draw a cause and effect. What does a random selection from the population make happen? What will be the quality of my sample? It'll be representative. So if my sample is like the population, then you can generalize. So if my sample's like the population, you can generalize. Randomly select, no effect. That's not what allows you to do a cause and effect. Randomly select. You know, you randomly select. If your sample's like the population, you can generalize. When you make an experiment, you must randomly assign. You randomly assign to the treatment groups. So your treatment is the Y. This allows you to draw, randomly assign allows you to do what? Determine cause and effect. Because you have changed everything and your treatment is the Y. Now, one thing here. Oh, you know what's a bummer about an experiment sometimes? They were volunteers. So can you generalize to the whole population? No. Yes. You know, at first, or you can say you can generalize to all people that are like these volunteers. Okay, because volunteers could be desperate or whatever and have a different quality of things. All right. Next, experimental units are the subjects or the people or whatever in the experiment. Let's talk about factors. The factors are those explanatory variables, those things such as your medicine that you take. That is your factor. Okay, that's the explanatory variable that you're testing out in your experiment. And the level is going to be how many degrees of those you have, such as 0 milligrams, 5 milligrams, 10 milligrams. Okay, those are examples of 3 levels of medicine. Okay, treatment is that one that you randomly assign them to. Okay, we know that. Control refers to when you're trying to control the experiment. You want to control things such as if you know a particular trait will affect the way subjects respond. If I see you have a trait that affects the way subjects respond, then I want to control that. Okay? What if males and females, the estrogen in the female body makes the active ingredient in a medicine kind of fizzle out? Like if you mix iron and calcium, so if you take iron and calcium supplements at the same time, that kind of, they make each other, I think the iron cancels out the calcium or something. So you're just wasting your time taking that calcium. It's the same thing. What if like the estrogen in the females affect the medicine? So then should you compare should you leave it to chance that you get half males and half females when you do just a random assignment. What happens if estrogen makes a difference and you 15 females and you got 15 males and 85 females? What happens if estrogen has an effect on the drug? What happens if this group does better? Can you tell if it's the drug that is fixing it? No, you can't tell. It could be just that they had less females screwing up the medicine, inactivating the active ingredient. Okay, that was not a very clear discussion, but there you go. Okay, another thing, lurking variables. Lurking variables, the story we have for that is you have a variable that makes it look like there's a link happening, such as, a lot of firemen come to a fire and they cause a lot of damage. So are you going to say, and the fire has a lot of damage, are you going to say that the firemen are the ones that cause the damage? Firemen will cause the damage. It's what they do. Okay, is that what's causing the damage? What's the lurking variable? The size of the fire. The seriousness of the fire brings more firemen to the fire and makes more damage to the structure. Okay? A control group is a group that receives no treatment. A control group is a group that receives no treatment. Placebo, which is a fake or dummy treatment. Why might you choose to give somebody a placebo? If the response is psychological, such as how I feel, if my pain is better, if my mood is better, if my anxiety is less, whatever, I could think that it's happening because I took the pretty pink pill, okay, as opposed to the ugly brown pill that somebody else had to take. I got the good one. So if it has a psychological effect, then you want to nullify that effect on the whatever, which I guess that in itself is probably not ideal. You want to make those two pills look the same, or else that in itself could be causing a problem. Yeah, so sorry, wrong thing to say. I'm taking a pretty pink pill, and it's going to make me feel better. I don't know what you're taking. Yes? Well, so that's a good question. See, you would randomize to spread those unknown traits evenly amongst the treatment groups. Because if you think you need to control their pain tolerance so that you stratify first or block, and then do the test among the high tolerance people, and then do the test among the medium tolerance people, or whatever. If you think that people are truthful about how they feel, fine. Otherwise, you're going to rely on randomness to spread those qualities, like you're going to have an even number of those in each group, or something amongst that. Okay, how about blinding? That is when the person doesn't know. Single blind is what? Subjects does not know. Single blind, subjects does not know. Double blind? The researchers and the subjects do not know. Okay, randomization, we're going to talk about that whenever we... Okay, well, I'll tell you right now, the randomization, the key there is you want to spread unknown traits evenly. And that's what I put in my song. You want to spread any unknown traits evenly. Okay, that's what you're hoping to do when you randomize. You are also hoping to reduce bias. When you need to spread unknown traits evenly, randomize, randomize. When you need to spread unknown traits evenly, randomize, randomize to reduce bias, reduce bias. Okay? All right, now, and of course we know what bias is. Okay, so let's talk about these last three things here, these types of designs. Okay, there's a picture of them on the next page, so let's actually kind of go here to the middle of the next page where it says experimental designs. Completely randomized means you didn't control anything first. You just, after you got your subjects, you straight up put everybody in a big bag, and you, remember doing this? You randomly assigned to the treatment groups, and you on that you would describe how you would randomly assign. Randomly assign to the treatment groups, so you can claim a cause and effect. Now, what are the three principles of experimental design? You make an experiment. What do you do? Control, randomize, repeat. You make an experiment. What do you do? Control, randomize, repeat. And then randomly assign to the treatment group so you can claim a cause and effect. So suppose that I see you have a trait there that may affect the way subjects respond. Then I want to control that trait, and I will do that controlling first, and I will control that by blocking you into homogeneous groups. So blocking is controlling that trait that you think will affect the way subjects respond, and then within each block is experimentation. So within this upper block, I will then randomly assign. See? Control first, then randomize. Control, randomize, repeat. Within each block is experimentation. All right. And finally, we've got this matched pairs design. So let's talk about a couple. There's two different ways you can have a matched pair. Let's talk about one way. Say I want to compare a way to, let's see. I want to compare Coke as a marinade or Dr. Pepper as a marinade to ribeye steak. Okay? So what should I do? You know, because it'll tenderize. Maybe a tenderizer, I should say, rather than marinade or whatever. So what should I do to have a matched pair situation? Identical steaks, identical in weight, age, cut, fattiness, whatever, and then flip a coin, and one of them goes to the Coke, and one of them goes to the Dr. Pepper. Okay, matched pairs. Remember in the Holocaust, if you were a Jew, that was sad. If you were a twin Jew, then you didn't go to the concentration camps, you went to the scientists. Okay? So that they then used you as a matched pair and did all kinds of things to you. All right, what's another way you can have a matched pair? You can be your own matched pair. Me before the treatment, me I take the pill, and then me after the treatment, and I compare my before to my after. Have I controlled all of those variables? Everything. What's the difference between my before and mine after? One thing only, and that is the treatment. One thing only, and that's the treatment. All right. So we got the songs that we're going to be doing. And then your assignment is going to be, so your homework is going to be the multiple choices on pages 53 to 60. Okay? All right, and so then we'll sing the songs now too.